same information, but what is the probability that I make exactly 15 baskets? Now, asking an exact value of a continuous distribution is a weird thing to do. After all, under the assumptions of the normal distribution, the probability that someone is, say, exactly 6 feet tall, that can't happen. But if I shoot the ball 65 times, could I make exactly 15 baskets? Sure, it's possible. What you do is you treat it like a between. You do it between 14.5 and 15.5. So let's work out what those numbers are. This one is 0.13, and the other one, 0.16. And this one, of course, will be negative. Negative 0.13 and positive 0.16. And what do we do with each of those values? Yes, we look them up on the z-table. Negative 0.13, 0.4483. And this one, five, 9, 6. And what do we do when we're finding the probability that x is between two values? Yes, we subtract the table values. .1113. So there's about an 11% chance that I would wind up with exactly 15 baskets. 15 is the most likely outcome because our mean is around 15, but there's only an 11% chance that I would get exactly 15. So, the steps to use the normal approximation to the binomial distribution are: find your mean and standard deviation, correct for continuity to get your x value, use the z formula, find the table value. Now, remember how we had that other formula for binomial distributions? Other formula? Yeah, there was another formula. It kind of looked like this. Remember this formula? Well, we also use that for binomial distributions, the same type of problem. So how do you know which one to use? Well, it depends how big n is. If n times p is greater than or equal to 5, and n times q is greater than or equal to 5, use the normal distribution method. If your n is small, so one of these doesn't work, you have to use the formula. Me, I prefer the approximation. It's easier.